Good afternoon, everyone. My name is Mike Oakes. I am a solutions or sales engineer for DDN Storage. Today we're going to be talking about deploying a high-performance CDN storage infrastructure for tomorrow's modern enterprises. More specifically, how DDN helps to address some of those infrastructure challenges within our solution appliances. We aren't a CDN, but we do help enable CDNs. So I'd like to tell you a little bit about DDN real quick. I got about 30 minutes. A little bit about our product, what we see some of the challenges are, and how we help solve those. So DDN was founded in 1998 by two gentlemen, our co-founders who still run the company today. There are no VC or venture capital. We are fully self-funded, privately owned. We are one of the world's largest private storage companies in the world. We are headquartered out of Chatsworth, California, but we have facilities around the country, around the world. I don't think you can see it too well up here. Some yellow dots, there's Los Angeles, there's Paris, there's Tokyo, which are some of our main hubs, basically our international hubs, but we also have facilities for development, service, and support worldwide, as well as sales. Basically 7x24, 365 support, sun never sets. What you're seeing here, quickly, we're going to talk more about the web, cloud, and telco section. These are the four main verticals in which we play, along with some of the customers we have in each of these verticals. It's more important that you understand who or what these verticals are to what we do. I mean, our breadth of knowledge, our breadth of actual appliances that we actually put together, and our PS services. Right, so each one of these, has a specific requirement, but they all have a bandwidth requirement, very low latency, right, and very, very high HA, right? So they need 5, 10, 15 nines capability. So a little bit about our product real quick. This is like a high-level overview. We're not going to talk a lot about the stuff to the left here, more along the stuff to the right. So more along the file-based storage. Do we do block? Yes. We have also at the top something called IME. This is our new product. It's called Infinite Memory Engine. What it allows you to do is take all kinds of unstructured data, dump it into this IME engine, and it will actually, it's file system aware, basically right now based on Lustre and GPFS, but it will reorder the IOs to put them evenly and sequentially down into the disks, so you're not needing thousands of disks on the back end to hit a high saturation point, a lot of writes or a lot of reads. This basically, think of it as a high burst buffer. But more importantly, what I was talking about is you see the GPFS grid scaler or media scaler product we have. But off to the right of that, you'll see things that's called object storage. This is where we have a big play with the CDN marketplace. What we do is, it is truly a non-file system-based object storage, right? So we can interface to it, and you see some CIFS, NFS gateways, WAS bridge here in the middle, S3 Swift gateways. They can interface into the storage in a single federated namespace, or you can have multi-federated, a cluster set up, but it can go from a GPFS or Lustre file system into the cloud, tiering with ILM, all automatic, so you don't have to worry about setting up your own policy base. Quick things about the WAS itself, as it talks about it, it's geo-distribution replication. We'll talk a little bit more about that as we get into the presentation here. So more quickly, what is our object-based solution? Right? So if you think of this as being origin content in the middle here, the larger set of storage blocks you'll see, and then you see outliers. Basically, it's latency aware. What do we mean by latency aware? There's constant algorithms running within the appliance, looking at all the different locations around the world to see who's fastest, who's slowest, is somebody down. It will start to reroute content automatically, so you don't have to worry about doing this on your own. With monitoring stations, you can look at it, but you don't have to take an action. The cluster is smart enough to do it for you. Automatic replication, which kind of goes into the policy-based SLAs and things I was talking about a little bit earlier. So there's 4 different types of SLA policy you can have this. Everybody does replication. We also do something called local object assure, erasure coding. Think of it as RAID, but not RAID. It is an 8+10 type of algorithm setup, but what you can do with that is it's never written the same shard, and we'll call a shard a set of, maybe it's an 8 meg file. We'll write 1 meg to each disk drive in an 8+2. And we'll never put the same 2 pieces of a shard on the same drive. Should you have a failure, you're only rebuilding just those small pieces or small shards on that one drive, and you get the full bandwidth of the entire drives instead of always writing to the same RAID set. Coupled with that, there's replication for LOA, as well as we call GOA, Global Object Assure. This allows you to actually have multiple facilities around the world. You can actually place data where you need to strategically. And should one facility fail, the others will pick up the load and actually give the data out. Now, you are subject to speed of your WAN. So the slower your WAN is, of course, the slower your time to customer with that replicated data. Flat namespace, I talked about, and tunable security parameters. So real quickly, what we see ourselves addressing here in this market, high availability, of course, we just mentioned the talk about replication, right? Minimize time to first byte. This is where we are very, very good. And the reason why I say that is a lot of storage products on the market today, when you write data in, it's set to a specific write size and set to a specific write size to go to disk. We give you 250 dynamically selectable, and the storage does this for you, basically write patterns as small as 1 byte and as large as 1 meg, and in between to get the right data to fit in the right bucket at the right time, which means you're using about 98% of your storage efficiency. So you're not wasting all that storage on a small file that doesn't fit the stripe size. Along with that, multi-site distribution, we can pretty much go anywhere in the world, latency in microseconds, and we use broadcast live streaming. We'll use that GPFS file system I was talking about. It gives you the ability for basically catching streaming files, right? So anything that's growing. So for all of you in the room that actually know this workflow, this is what we basically see as the origin content on the far side, mid layer in the middle, maybe some edge or last mile. Where we see ourselves collapsing this is in the middle most of the time. What we'll take is we'll be origin on the front side, and on that last mile, you can place servers pretty much around the world, and this is just 3, but you can be anywhere. And by policy, you can put data into any one of those, all of those. If a facility's down, it will automatically replicate to another one. It will always keep 2 copies of data in the cloud at any one time. Even when you ingest data, it'll actually make 2 copies locally and then push them to where they need to be by policy, and then allow you to delete that data. Actually, it does it automatically off the storage to free up the space where that data was not supposed to be placed. Am I going too fast? I'm trying to get in within 20 minutes so you guys have some questions, just in case. This actually is with a single namespace. We're talking about using a file system, right? So I can ingest on the front side, high performance SSDs, high performance file system. Take that data in, and by policy, now I can push it automatically straight to the cloud anywhere it needs to go. Your user can actually, if you want to do collaboration worldwide, you can have other file systems on the other side of the world. Actually, we call it rehydrate that data out and actually use it for content collaboration, as well as doing any kind of real-time streaming that needs to be required. If you have data come in, maybe it's down in South America, but by policy it was supposed to be in New York and somewhere in China, doesn't matter. The data can come in at any site, but will be geo-positioned where it's supposed to be by policy, literally instantaneously, however long it takes your WAN to get that data transfer over. So, and I actually went really fast, only took 10 minutes. So, the conclusions here, right? So we accelerate the business model with results, basically reducing the infrastructure, right? I flatten out your infrastructure. It's quicker to end-time user, and it's actually more efficient for internal usage. Data security replication, optimization, content anywhere. That's basically it, ladies and gentlemen. I went quick. Any questions? Sir? It's the speed of the WAN. We actually have it. You can have name servers in every location if you want. You don't have to. And if you want to do something with, maybe you want to do human readable instead of using an object base, we do have sys NFS gateways that stay synced worldwide. So you can have that federated namespace. Just depends on the speed of your WAN.
What about edits, though? What if the person in LA does edits on it?
It'll put it back as a new object, but if you're doing it as a file-based, it'll see that edit change because it's a different name. It's a put, get, delete when you look at the core of the file system. But actually, when you're done, at the end of the day, when you put something back, it's just a new object. Now, you can keep that data translation map, between object ID and namespace, or we can do it. Because we have several different APIs that I forgot to mention. One of them was WASLib, which is basically an API you can write straight to.
How many of your customers use the API versus the object store?
All depends on the workflow. Typically, you see about 30% using the API, another 45% will use a hybrid model of both API and file system. And you can do both. The only time you can't do both is if you're using S3 right now, unless you write through the file system with S3. If it's S3 on the back side, it's a separate database. Sir, in the back. I'm sorry, I couldn't hear you. So what it replaces is your need for, so a lot of times you'll do replicate, I'll take the replication example. So everybody wants to do replication, but it's quite expensive. For every 100 terabytes, it's another 100 terabytes, right? What we do is you allow to collapse that. If you're using local object assure, you collapse down to 1.25 times the size of whatever file you're storing. So we're actually collapsing infrastructure, but allowing you to expand when needed and actually collapse when needed. These appliances can be pulled in and out of the cloud as needed simply by assigning an IP address or taking an IP address away from the cloud. It will redistribute the objects around the world where they're supposed to be and allow you to actually repurpose your data without having to do forklift upgrades and moves of entire facilities. You can just move as needed data and equipment. Follow up? I couldn't. It was on. You say on the cloud? Yeah, it's cloud-based. So you can do it. We do it in the cloud. We call it WAS, Web Object Scale. It is our cloud. You can be a private cloud or a public cloud or a hybrid of both because it is multi-tenant. It does integrate with Active Directory and allows you to get a lot more feature set out of it. So with the file-based stuff, it's not true cloud because it's a file system, but we push it into the cloud via policy mechanisms and rehydrate via policy mechanisms. That answer your question? Okay. Anybody else? Sir? Most common use case is for things like tablets and phones right now, both internationally and domestically. We supply quite a few of the private providers that I can't name the ability to share that data worldwide. But if you got a phone, you probably know what I'm talking about. Anybody else? No? Thank you.